All right, we're going to continue in Chapter 1. Section 1.2 talks about data classification. Welcome back to our stats class. There are two particular types of data that we're going to talk about. The first one being qualitative, and the other one being quantitative. Qualitative data consists of attributes, labels, or non-numeric entries, so some quality about the data. Quantitative consists of the numeric measurements or counts, so quantity. Example, the table below shows sports-related head injuries treated in the U.S. emergency rooms during a recent 5-year span. Which data are qualitative and which are quantitative? So qualitative would be the things that are non-numeric entries. In this case, it would be the name of the sport. So all of these are qualitative. The quantitative data then would be the number of head injuries that have been treated at the emergency room. So if we look at this data, head injuries, probably no surprise, football has the highest. The lowest would be volleyball, and then everything in between. So qualitative is the sport, quantitative is the actual number of head injuries. We also have some levels of measurement, different ways we can measure this data. The first one is nominal. Nominal level of measurement is qualitative only. It is your one that only talks about qualities of the data. We can categorize it using names like we did with the name of the sport. You can use labels, you can use different qualities, but you cannot do any mathematical computations. Again, that makes sense. You're not going to add, basketball and baseball and come up with a new sport. That's not how that works. The next one is ordinal. Ordinal orders your data, so it's got the order part of it. It can be qualitative or quantitative. Basically, your data is arranged or ranked. So we're looking at first, second, third, that kind of ranking. The differences, however, between the data entries is not meaningful. In other words, you can't subtract it. Very much like you can't subtract basketball from baseball. The same thing. So you can't actually subtract it where it's meaningful. So looking at those two, for each data set below, determine whether the data is nominal or ordinal. So if we look at the first one, this first one, the top 5. So these are ranked. That is the top 5 occupations with the most job growth projected for 2024. Since that is ranked, even though these are words and they're not quantity, so this is qualitative data, but because they are ranked, this is ordinal. Because it is ranked, it is ordinal data. The second chart here is movie genres. They don't talk about how they're ranked. They don't talk about who likes most. In fact, if you look at the list, it's just alphabetical. So there's really no information other than it's a set of movie genres. So this one is just a set of movie types, making this nominal. It's the lowest level of data. It's just information. All right, again, here's another time where I want you to try these next two examples. So take a couple of minutes and decide whether these two are nominal or ordinal. And again, make sure you explain your reasoning. So why? Why do you think it is? That's similar to the way I did the above example. There are two other types of data that we talk about. The next one is called interval data. Interval is quantitative only. Since it is quantitative, we can order the data. The differences is meaningful. So if I were to look at the difference between the data, it is meaningful. 0 represents a position on a scale, not an inherent 0. 0 does not imply none, and we'll talk about that in just a second. The last one is the ratio level of measurement. It's very similar to ordinal. However, now that 0 entry does have an inherent 0. It does imply none. The ratio can be formed, and that's going to be very, very important to us, because from a ratio, oftentimes we refer to ratios as fractions, and if it's a fraction, we can move it to a percent. So this is where we're going to talk a lot about percent and how that's all related using ratio level of measurement. And one data value can be expressed as a multiple of another. That's, again, has to do with the mathematics of the data. Okay. Let's talk just really quickly the difference between an inherent 0 and a non-inherent 0. An inherent 0 would be when we talk about having $0 in your account. $0 actually means something. It means there is no money. All right. Versus 0 degrees Celsius. This does not mean that we have no temperature. So 0 degrees has a meaning that doesn't represent nothing. So in this case, 0 degrees, this does not mean there is no temperature. So an inherent 0 means you have no money, you have nothing. That 0 really means something. Versus 0 degrees, yes, it's on the scale. It means that it's cold outside, but it does not mean there's no temperature. There, in fact, is temperature. And we'll talk more about that as the course progresses. All right, next example. Two data sets are shown below. Which data set consists of data at the interval and which is at the ratio level? So if we look at the first one, this is New York Yankees World Series victories. There are a group of years from least to greatest. Those are years. They're numbers, but more specifically a year. All right. So this one would be an interval. Okay. Again, because they're numbers, they're quantitative. They are in order. Okay. Difference does have a meaning. So when we think of the difference, oftentimes we're thinking subtracting them. So in this case, if I were to take 2009 and subtract the 1923, if I subtract those two, then that tells me that I have 86 years between their first win and their last win. So there's 86 years between the first and last victory, World Series. Right? But if I look at 1923 divided by 2009, that doesn't do anything. This is your ratio part of it. And in this case, that ratio means nothing. This doesn't mean anything. So there's not a whole lot you can do with that. It's just a date divided by a date. There's nothing there that you can do anything. versus, if we take a look at the second chart, 2016 American League home runs by total, all right? Again, this one is now going to be ratio because, again, if we go through it, it is quantitative. And we're looking at the numbers here, not the team name. We're looking at the numbers. All right. They are not in order, but that's okay. It doesn't matter. They're in alphabetical order, but they're not in order by the total number of home runs. Okay. The difference. Can we take the difference of this and have it make sense? Well, if we look at the Astros, and we want to know how many more Astros we had than New York, so Astros versus New York, then I can say, well, the Astros had 198, New York had 183, so 198 minus 190 or 183 says that the Astros had 16 more home runs. That means something. That's a quantity we can talk about. It means something. And now for the ratio part. So this time, let's compare the Astros to LA with a ratio. So the Astros had 200 home runs. Oops, had 198. Wouldn't be 200. It's almost 200. So 198 divided by 156. And if we take a look at that number, that's going to have a meaning to us. So if I look at my calculator, 198 divided by 156, that's 1.269, or we can say 1.269. We can say that the Astros had approximately, that's what those two little squiggle marks mean, approximately 1.3 times as many home runs. So that number actually means something. And that's the difference then between an interval and a ratio. That number actually means something. Okay. All right, and this is going to give you an opportunity now to try one of these on your own. So again, try one of these and see what you get and what your thoughts are. And again, explain your reasoning. Go through what you think it is and explain how you came up with your conclusion. Okay. All right, and then the last thing we're going to do is summarize these 4 levels of measurement and looking at the least to the greatest. So nominal is your least level of measurement. You can do little to that. Ratio has the most power. It's the one you can do the most things to. So can we put the data in categories? Yes. In each one of these cases, they can all be put in categories. We can take this and put things into different categories. Can we arrange the data in order? Well, if it's nominal, arranging it doesn't mean anything. But ordinal means order, so yes, we can put that data in order. For intervals, we can also put it in order, as can we do ratio. Can we subtract the data values? Does it make sense to find a difference between them? Subtracting meaning difference. Well, nominal, they're not even numbers, so no. Ordinal is a ranking system, but that's it. Interval, yes. And ratio, yes. You can subtract them. Determine if one data value is a multiple of the other. This is where the actual ratio comes in. So mathematical, it's talking about a ratio. Can you make it a multiplier of the other? Well, no, of course, for ordinal and for nominal. And that's the distinction between interval and ratio. So nominal does the least amount of information. Ratio gives us much more information. All right, and that wraps up section 2, short and sweet. Thanks for being here.